Welcome and thank you for joining the Boston University Institute for Global Sustainability for today's Research for People and Planet webinar. The title of today's webinar is Justice, Energy, and Transport, Key Climate Mitigation Insights from the IPCC Report. I'm Philip Warburg, a Senior Fellow at the IGS, and I'm pleased to host this webinar. The Institute's research areas are planetary and environmental health, climate governance, and energy systems to advance a sustainable and equitable future. We're delighted to welcome everyone who's joined us and encourage you to visit the IGS website at bu.edu/IGS. Some quick housekeeping notes. The recording for today's webinar will be available on the IGS website and will be emailed to everyone who registered. To ask questions, please use the Q&A button at any point, and we'll get to as many of your questions as we can. Our speaker today is Benjamin Sovacool, Director of the Institute for Global Sustainability and Professor in the BU Department of Earth and Environment. He is also a lead author for the third part of the IPCC's sixth assessment report titled Climate Change 2022, Mitigation of Climate Change. And now, Benjamin Sovacool.
Thank you so much, Phil. And it's a real pleasure to be here. It's really nice to talk today about the IPCC report. It is 8 years in the making since we've had the last one, and almost all of the authors work voluntarily. So we're spending months of our life for free because we believe in the purpose of climate science. As Phil mentioned, this is the third part of the working group looking at climate mitigation. You can see the whole report here. Published throughout 2021, 2022, and recently 2023 with the synthesis report. It's free, but I will warn you, it is long. Thousands of pages, would probably fill up a suitcase if you printed it out, which means it's full of rich, really good data and evidence synthesis. I wanted to give today a very quick high-level take on some negative trends and some positive trends from the report. The first is the bad news, Phil. The bad news is, well, unfortunately, even though we've known about climate change for 50 years or longer, and we've been really pushing aggressive climate policy since 1992, it's not working. Emissions continue to increase. They've even continued to increase over the past decade, with billions of tons of additional carbon equivalent emissions. This graph also indicates it's not just carbon. It's also other greenhouse gases like N2O, methane, or these industrial gases that are human-made called F gases. All of them are increasing. All of them are increasing faster than we can offset them. Secondly, it's not just the US. So even if we were to somehow tomorrow reach climate consensus, this graph shows actually a shift in emissions. Historically, it's the US, North America, and Europe that are responsible, as you can see in the bottom left, for 2/3, 1/3 to 2/3, depending on how you count, of emissions. But going forward, between now and the end of the century, it will be developing countries. 75% of future emissions are not in the global north, they're in the global south. Asia, Latin America, and the Caribbean, and Africa. So we see a shift from historical trends to future trends. And finally, this is really confusing to a lot of people, but even if we were to cease emissions tomorrow, climate change would still occur because there's a lag in terms of what we've emitted into the atmosphere and how long it will take to stop to create temperature change. So you can see here on the left graph, even if emissions stop in 2022, we will still see a committed warming of 1 to 1.8 degrees. That's the right graph. Which means we're already locked in. Climate change and our embodied emissions are already locking us in for pretty significant temperature change, even if we achieved complete decarbonization tomorrow. And of course, we're not likely to do that. This is the core scientific graph in typical IPCC style, a bit confusing. This gives projected temperature change. I like to focus on scenario C8, which is at the top. Scenario C8 says we have a greater than 50% chance of seeing temperature change greater than 4 degrees, which is catastrophic. This level of temperature change, as a published article in the Transactions of the Royal Society indicated, will exceed our ability to adapt. Human systems won't be able to adapt in most parts of the world, and natural systems will collapse. Oceans, forests, streams, habitats, and species. So it's a nightmare scenario. As Barack Obama used to say 10 years ago, we actually have three choices with climate change: mitigation, stopping emissions; adaptation, building resilience; or death. And unfortunately, we are currently on track for the death. However, now moving to some of the good news in the report, we do have an arsenal of new technologies, many of which are in energy and transport, that have seen remarkable improvements in cost, performance, deployment. The IPCC features these ones here: solar panels, wind, onshore and offshore, concentrating solar power, and of course, electric vehicles. These are exceeding expectations. Solar energy is anticipated to be the world's largest energy resource in just 10 years. It will overtake potentially fossil fuels. And we're growing our cache of electric vehicles from 1 million in 2015 to an expected 1 billion in 2050. That's growth of 1,000-fold, 1 million to 1,000 million in our generation. And you can also see that there's a whole suite of other non-energy and transport technologies. This graph gives you basically the whole report and all the options we have to fight climate change. You can see some of the energy and transport options here, like I mentioned, solar and wind, biofuels and EVs, but also a whole variety of things in agriculture, or buildings, or industry, or even capturing non-CO2 greenhouse gases like methane and some of the short-lived climate pollutants. This graph has a lot to unpack. It's actually showing you also potential costs, as well as potential efficacy in terms of how many gigatons of carbon it can save. So the bigger the bar, the more potential. And what the graph clearly shows, according to the IPCC, is the technologies with the most potential to stop emissions are wind, solar, better managing forests, better managing agriculture, and fuel switching for industry. So that also kind of gets you a priority list of like the short, sweet, low-hanging fruit we have to pick to fight climate change. What's also interesting about the report is it's not just about technology. So for the first time ever, the report featured Chapter 5, which is about demand and behavior. And this chapter actually indicated that we can reduce energy demand and emissions by up to 70% by 2050 if we just change our demand practices. And you can see that in this graph where it says sociocultural factors. If we shift our diets, if we avoid food waste, if we stop over-consuming, if we stop driving cars, if we do more teleworking, if we have different lifestyle changes, these are very important and are just as important as technology and infrastructure in avoiding emissions. And a final piece of good news is it's not just the nation-state system. In my chapter, I had the pleasure of working with a team of scholars who study subnational actors. These are cities, corporations, industry associations, and voluntary kind of pledges. And what we've shown here is that these pledges, if you add them up, have a level of ambition that is greater than the COP system under UNFCCC. So I'll say that again. We could save more emissions from actions outside of the nation-state system than we will through all the UN discussions about NDCs and COPs. And if all of these pledges are realized, which is prone to some uncertainty, we could save about 20 gigatons of carbon, and we're only emitting about 50 gigatons of carbon equivalent. So we can reduce emissions by almost half if we continue to harness the power of these non-state actors, which are cutting emissions faster and quicker than a lot of countries are. Final theme I wanted to bring to your attention, besides positive and negative messages, are the many ways in which climate change intersects with equity and justice and quality of life. This comes from the synthesis report, which was just published a few weeks ago, and it shows you all of the positive and negative ways all those climate mitigation options intersect with the UN's Sustainable Development Goals. These are goals like ending hunger, reducing poverty, promoting gender equality, protecting life above land, life below water. And everywhere you see a plus, hooray. that means that there's a positive synergy. But everywhere you see a minus or a dot, there's a trade-off or a negative synergy. And you can see a lot of mixed results, which kind of means that it really depends how we deploy these technologies. And that's why the report also delves deeply into this notion of a just transition, which I strongly support. The report does an excellent job defining a just transition, and I love this. This is both in the glossary and in chapter 4 and in the technical summary, so it's 3 places in the report. A just transition is a set of principles, processes, and practices that ensure that no one is left behind. No people, workers, sectors, countries, or regions. So there's spatial elements, demographic elements, place-based community elements as we do this transition to fight climate change. And the just transition concept also says we have to intervene. It justifies the nation state and others that actually proactively manage and eliminate negative impacts, maximizing benefits for vulnerable groups. And it also is about different principles of respect and dignity and dialogue and social consultation and decent, high-paying jobs and protection of human rights. Which means the just transition is a beautiful concept that cuts across different dimensions: energy, climate, land use, rural affairs, environmental planning, and it is also about promoting gender and equality and class, and also minimizing poverty. It finally argues there's a historical responsibility, a moral responsibility to redress past harms, make the polluter pay, and basically implement a degree of restorative justice. This is why I'm so pleased the report has documented multiple nations, commissions, task forces, and social movements that are already committed to a just transition. And this is already out of date because we did this mapping in 2021 to have it published in 2022. And it also underscores, again, the non-technical need for systemic, multidimensional change. It isn't just technology. Look, technology and innovation are one small box. We also need to create enabling conditions for governance, for policy, for finance, for behavior change. And if we can do that, it will create a virtuous cycle that accelerates mitigation and shifts us on more equitable, sustainable development pathways at the same time. As my colleague Amory Lovins has said, this makes climate policy the free lunch you get paid to eat. And with that, I'm very happy to open it up to Phil to tell me about questions. Thank you.
Thanks for that great and sobering look at our climate future. You spare us the sugar coating, which is wonderful, and you also present some great opportunities. Here's one question that came in. How do we shift the world's attention from developed to developing countries when it comes to the need to decarbonize, to finance the transition, to adapt, etc.?
So there's a great question, and it's a complex answer. I think, first of all, we still have to accelerate technology transfer and kind of accelerate this norm of responsibility that North America and Europe and other industrialized countries have a duty to help developing countries decarbonize. We have a Green Climate Fund, which is not that invested in. We had previously a Least Developed Countries Fund, which put about $1 billion into adaptation in 66 least developed countries. It sounds like a lot, 985 million, until you realize in a global economy of 100 trillion a year, that's peanuts. So I think we have to first continue to accelerate the global north, helping assist the global south in non-colonialist ways that they need. But secondly, I think we have to just continue to harness these subnational actors, which already exist in the global south. Many of the world's future factories are being built in China and Africa, not North America. And many of the top Fortune 500 companies have supply chains in more than 150 countries, whether they're making shoes or concrete, steel or hamburgers. So I think they're very well primed to help address decarbonization in the global south. And I think finally, we need to realize that we should let the global south lead. So there are some very particular areas like agrarian agricultural systems, maybe leapfrogging to mobile phones and digitalization, and other neat innovations coming out of the global south that we should just respect and give them the autonomy and authority to lead. This discussion of loss and damages is a good way of starting to fund some of those innovations, but I think it needs to go a whole lot further. Our work at BU's IGS has shown global energy and transport externalities, so the hidden social impacts of energy and transport, could surpass more than 20 trillion a year. So 1/5 of GDP. That implies society is already suffering and paying the cost of inaction. 20 trillion seems about right as an amount that we need to invest in the global south. So I would be all for funneling 20 trillion in the global south efforts to decarbonize. Future generations will reward us for that.
Well, that relates to a question pertaining to electric vehicles. What do you think about EV and decarbonization within the context of this huge transformation that we need to face?
I'm mixed about EVs. On the one hand, they have a lot of benefits for air pollution. They're more affordable to drive. They're certainly cleaner and less minerals intensive if you account for extraction of oil. I even saw on Twitter, not the most reliable source, a tweet going around last week that says that EVs are 535 times less materials intensive than fossil fueled cars. Right? So while we hear about mining and impacts, it's like, let's put it in perspective. That said, EVs still have their own issues. We still have lithium and cobalt and copper mining in regimes around the world that hurt artisanal miners. We still have the mounting problem of electronic waste. And finally, EVs are autocentric. It's still driving a car on a road, which means more road building, more highways, etc., where I really think the future mobility system for all countries should be a lot more active, a lot more walking, ride sharing, a lot more cycling, and a lot more public transport, even in the global north. So I'm a little worried about EVs entrenching autocentrism. I think if you integrate them well with intermodal transport, like ride sharing regimes, mobility as a service, micromobility, e-bikes, e-scooters, so it's not just more cars. That is a far more sustainable and diversified future for mobility.
Great. Another question is, there are still some people in the US that believe misinformation about climate change. How would you recommend we explain that this IPCC report should be a trusted source of information?
I don't know, because a lot of those communities that are resistant to facts are resistant to facts. It's like giving them more facts doesn't really solve that conundrum. I suppose you could frame it perhaps in a few other ways. You could change the frame to one of, well, what if you're wrong? I understand you don't believe it, but if you're wrong, right, the stakes are so high that you do it as a hedging strategy, a plan B, a risk mitigation strategy, which even the most steadfast of conservatives will still recognize, because you always hedge uncertainty and you always want to reflect that what if I am getting the wrong information. But more importantly, I think there's a case, and this gets to some of the co-benefits that I mentioned in the presentation. You can do climate action for non-climate reasons. Okay, you don't want to do it for climate change, do it for jobs, do it for resilience, do it for energy independence, do it for fuel savings, do it to avoid air pollution, do it to create innovation, green growth, patents. There are a whole variety of other positive ways. We've done research on low carbon transitions and identified 128 co-benefits beyond climate. 128. So I think do it for those reasons. Do it because there are great ways to generate revenue, patents, cut costs, and provide more equitable pathways separate from climate change. So I guess it's shifting the narrative to capture economic, political, and non-environmental benefits.
Great. Here's one that brings other energy sources into the picture. Bloomberg is heavily invested in natural gas. Do you see natural gas and carbon capture as energy number one, question mark?
No, not as energy number one. I think there's a legitimate debate about gas and nuclear and big hydro. So the way that I have envisioned energy systems, and this is reflected a bit in chapter 6 of the report, which is energy systems, you kind of have three sources of energy you want to get rid of no matter what. Oil, coal, and arguably waste to energy, waste incineration, which has very high externalities, unless you're doing it well. Right, like capturing methane and accounting for other forms of waste. Waste to energy has more externalities than coal, according to some of the studies we've looked at. So those are the three dirty systems. Then at the bottom, you kind of have the sweet low-hanging fruit that I showed earlier. Solar PV, offshore wind, onshore wind, energy efficiency, load management, and then in particular configurations, geothermal, microhydro. Those are great. Almost anywhere you do them, they're great. Then you have what's in the middle, big hydro, nuclear, and gas. And that's where a lot of debate happens. A lot of people will draw lines and say everything but gas or everything but nuclear. And I think that's a legitimate debate. What's less debatable is that all three of those options are still better than oil and coal. So I think that, yes, it's number one compared to those, but number 6, 7, or 8 compared to the other options that are more decentralized, less fossil fuel intensive. I do think we will see widespread CCS deployment in our lifetime. I'm not sure it's going to be done at power plants anymore. And that's for 3 reasons. One, we've already done a great job decarbonizing electricity. So it's kind of like we don't need more help there. Wind, solar, efficiency, hydro, even nuclear are all helping decarbonize grids. Electricity decarbonization is happening faster than any other sector. So it's kind of like we should go to where we're having difficulty, not to where we're already decarbonizing. Secondly, CCS will have to occur and could occur in industry, where I see a lot of hope, where you can have it for cement and concrete and steel and refining, where there's just very little other options, especially in the global south, where they're going to still use fossil fuels for the next 50 to 60 years. So I think we will tend to see it more at smaller scales with lower volumes of carbon. And finally, there's an interesting coupling between CCS and blue hydrogen and green hydrogen that could also integrate renewables, nuclear, even tidal energy in a future energy system. So I think if those couplings occur, then CCS is a key part of it. And in fact, you need depleted oil and gas fields to store a lot of the carbon. So I think there is a role for it, but it's not like the panacea utopian solution where we've got a hydrogen economy. I see it as more integrated and coupled into low carbon architectures that are predominantly non-gas.
Given the prodigious amount of work that everyone has put into the 6th assessment, this question seems relevant. What piece of the report do you recommend for a detailed enough, but not too detailed overview? The audience would be corporate board members and management teams addressing or struggling with their decarbonization journey.
So the report is designed to have a really nice summary for policymakers. It's called the SPM, if you want to really sound like an IPCC geek. It's shorter, and it's meant to do just that. It's the most negotiated part of the entire report, and it's the one that goes through edits for communication to a more general audience, especially policymakers and corporate leaders. So there's the executive summary and the summary for policymakers of all 3 working groups. And then there's what we just published 2 weeks ago, which is the synthesis report, which is still shorter. It's not short, it's still dozens of pages, but it's shorter than the whole report. And that's kind of the official message that the IPCC is allowed to say they approve. That said, we've got 3 problems with the IPCC's messaging. Number 1, it's not supposed to be policy prescriptive. The mantra the IPCC tells all of its authors is policy relevant, but not policy prescriptive. So it's not our job to provide policy recommendations. Unfortunately, huge missed opportunity, but that's what it is. So you have to interpret the results. Secondly, it's already out of date, right? Because the first parts were published 2021, data collected 2020, it's now 2023. So things like Ukraine, things like recent changes in geopolitics aren't really in the report, in those parts of the report. And finally, the amount of evidence we had to synthesize was so vast that this is the first time we used a lot of machine learning and systematic reviews, which have potential biases, right? To put this in perspective, the amount of literature that we had to assess in this cycle of the report is greater than all 5 previous reports combined, right? It's like every day is 5,000 articles published relevant to climate change, right? So it's impossible for us to read it all. No human can do that. So there could also be potential biases in the way that we synthesized evidence that will become apparent later, or that we reflect existing biases in the scientific evidence base. Lots of men, lots of people from North America and Europe, and lots of focus on what's called weird countries, Western, educated, industrialized, rich democracies, which may not apply for any society that isn't much like those. And the final thing I'll say that if you are talking to a corporate executive, there are great sections of the report that talk about corporate social responsibility, subnational action. So you could also just be very strategic, find those bits of the report, they're only 4 or 5 pages in the PDF, and craft your own summary for corporate leaders, which would be easy to do.
Terrific. I think we have time probably for one more question. Where do you put energy storage and batteries in the rankings?
You may have noticed that that big graph I showed that talks about the kind of mitigation potential and cost was medium supportive of storage, right? It's like whether it's hydrogen storage or chemical storage or battery storage or thermal storage. I think those options are kind of like CCS. They're like going to play a role, but we can't count on them. We can't count on them definitely in the near term because it just takes so long to deploy. But I do think that by 2030, the future energy system is a lot more modular, decentralized, and has a lot more storage on it. And I do think that there are probably 4 or 5 breakthrough technologies, I'm not quite sure which ones they are, that could revolutionize energy as much as shale gas, EVs, and solar PV have the last decade and a half. So we could still see future breakthroughs. It could be storage. It could be CCS. It could be hydrogen. It could be small modular reactors. We don't know. Or even other new technologies that are just beginning to emerge, like DAC, direct air capture, or BECCS, bioenergy with carbon capture and storage. So I think those frontier technologies, they create a lot of excitement. But one of the messages from the report is if you're talking mitigation in the near term, by 2025 or 2030, they're not a piece of the puzzle. They're not going to deploy at scale. And we really want to focus on those 6 things I did mention: fuel switching, wind, solar, agricultural land management, forestry. That's where you get the most emissions reductions. I'd much rather have you planting trees, to be honest, than developing batteries, although that's going to get me into trouble.
I think I'm not sure if we can fit one more question in, but there's a question about nuclear fusion technology, and I think you've kind of answered it in what you just said in terms of what we can count on in the near future versus imagine in the more distant future.
Fusion is amazing. I think it has a lot of potential. It could be the energy source that humanity relies on by 2050 or 2100. But even the fusion scientists I talk to are saying the earliest we will have commercially available fusion energy is 2050. And by 2050, we already would have had to have decarbonized. So I don't think we don't do fusion research, but we cannot count on it right now, given all the uncertainties and the urgent need to mitigate emissions now in our climate emergency.
Terrific. Well, thank you very much for being policy prescriptive as well as policy narrative. I think that's been a benefit to all of us, even though the IPCC has been very careful about that. Wonderful presentation. And I want to thank all of you for joining this webinar. Next up in our webinar series is Daily Heat and Firearm Violence in 100 US Cities. We hope you'll be able to join us on April 28th for this event. Thanks very much.